In this video, we are going to do a little fraction attack with simplifying expressions. So we're using the same skills of the distributive property and combining like terms, but now we're looking at some more complicated fraction setups. So as a reminder, anytime we're adding or subtracting fractions, we always need to make common denominators. So if we take a look at this example here, I notice right away that I don't have common denominators, so I'm going to need to make that happen before I can combine anything. So I do know that 7 goes into 14, so I'm going to go ahead and I'm going to multiply the left side of my fraction by 2 over 2 in order to make that happen. Now I'm going to distribute the 2 from the numerator to both of those terms there. That's going to give me 6x plus 4 over 14. Then I'm going to write it back here plus my x minus 4 over 14 that I had originally. And now I'm just going to add those fractions together. They have the same denominators, so I don't add the denominators, I just keep it the same. And then I'm going to add the numerators. So I have a 6x here and an x here. That can be combined for a 7x. I have a positive 4 and a negative 4. Those are going to cancel each other out, so I don't write them down. And then the denominator was 14. This already looks a lot better, but I'd also noticed that 7 and 14 can both be divided by 7, so I can simplify this even further to make it x over 2, and that is going to be my simplest form for this one. So it started as 2 separate fractions being added together and ended up as x over 2. Now your final answer might not always look that nice, so let's take a look at another example here. In this example, I noticed right away that the left fraction is using the distributive property, and I'm going to go ahead and do that so that everything is just a little bit easier to look at. So I'm going to distribute this 2. That's going to give me 14x plus 6 is over 5. And then I still have minus 3x plus 7 over 2. Okay, I want to subtract these 2 fractions, but I don't have common denominators. So I'm going to need to make those common denominators. Unfortunately, this time 2 does not go into 5, so I'm going to have to change both of the fractions. So I'm going to make the denominator 10 because I know that is a common denominator. So I'm going to multiply this side by 2 over 2, and I'm going to multiply this side by 5 over 5. So my first fraction, that's going to give me 28x plus 12 over 10. We're just distributing this 2 on the top and the bottom. Minus, on the right fraction, I'm going to have 15x plus 35 over 10. Okay, now you can do this a couple ways. If you're combining the like terms, you can do it that way. However, it's important to recognize that this subtraction sign is for both of these terms here. So it's really a negative 15 and a negative 35. So you could distribute that way and write it there. I'm just going to look at this one as I'm taking the 28 minus the 15 for the x's, and that's going to give me 13x. And then I have 12 minus the 35. That's going to give me a negative 23. And the denominator for all of that is still 10. I always want to look at this final form and ask myself, is there anything that I can divide all those terms by to simplify it further? And in this case, there's not, because 13 and 23 are both prime numbers. So that is the final answer on that one. Let's take a look at one more example here. Example number 3. And this one I have 2 fractions. They are a little bit simpler, but I also have an integer. Okay, and so if I'm adding these all together, it might be important to help me visualize this to write the 5 as 5 over 1, because I am going to want to try to add those all together, and they need to be similar denominators. So because of that, I'm going to change them all to eighths, because I know 4 goes into 8 pretty easily. So I'm going to multiply by 2 over 2. And then this fraction, I'm going to go ahead and multiply by 8 over 8. Okay, that's going to give me 3 new fractions that I'm then going to add together. So our first fraction is going to give me 4x over 8. I already have in the second fraction of 4x over 8, and that's kind of nice. And then here on the last one, I have 40 over 8. Now I can go ahead and I can add those all together. 4x plus 4x is going to give me 8x. And then I still have that plus 40. And they're all over 8. And once again, when I look at this, I notice that I can go ahead and simplify this. I can divide all of those terms by 8. So I'm going to actually end up getting 8x divided by 8 is just 8, and 40 divided by 8 is 5. So I'm actually going to end up with x plus 5 for this simplified expression here. Okay, so 2 of these 3 actually ended up looking a lot nicer than our starting one. Even that middle one there also looked quite a bit nicer